Hi, I'm Chris Bailey and I make Blender tutorials over at YouTube/CBaileyFilm, and today I'm bringing you this tutorial with CG Cookie. We're going to be talking about how to put fish scales onto any surface using geometry nodes. Let's get started. Now don't forget to head over to cgcookie.com. We've got a ton of amazing Blender training material and resources there for you, along with some amazing Blender artists ready to answer your questions. Head over and enroll today. Okay, welcome. We got a fresh scene here, and what we're gonna do is talk about how to use geometry nodes to procedurally put scales or fish scales across a surface. Now, fish scales are really complex. Let's have a look at why. Okay, so here's a picture of some fish scales, and you can see what's going on is that we've got these disc shapes like this that form the actual scales, but then they're offset on each row. So you get this alternating pattern where each set is offset just a little bit, right? So they kind of interlock and overlap in a specific repeating way. Okay, so let's get started. What we're gonna do first is pull up our timeline view. We're gonna switch this over to the geometry nodes editor. And then I'm gonna split my view here and I'm gonna grab my spreadsheet just so I've got some clear view on the numbers and what's going on with the actual things that we're doing. We'll talk more about this in a bit. So I'm also gonna get rid of my point light and my camera just to clean up the scene. So I'm just looking at the cube. Now, I actually don't want to use a cube. I wanna simplify this a little bit more so we can talk about the concepts first. So we're gonna use a plane. So let's go ahead and delete that. Shift-A, mesh, plane. With this plane, let's create a new geometry node. So we'll click new here and we'll just type in scales. Okay, so what we're gonna do first is I'm gonna switch to wireframe mode so I can actually see the mesh of this object, because everything we're gonna do is depending on the mesh of this object to get it to work. The first thing I wanna do is create a little more mesh, so a few more subdivisions. So we've got a few more vertexes to work with. I'm gonna go right here, Shift-A, and I'm gonna type in subdivide, and I'm gonna grab the subdivide mesh node. I'll drop this here. And I'll turn the levels up to 2, I think will be pretty good. Now, let's talk about what we're gonna do and how we're gonna make this work. The easiest way for us to do that is to instance our scales. So make our scales appear wherever there's a vertex on our piece of mesh. So we've just subdivided our mesh quite a few times. And so now we've got quite a few vertexes. That's each of these intersection points and right where each of these lines start. That's another one. And you can see here we have 25 now listed. So where each one of these things are, that's where we're gonna put a scale. So now how do we get that offset pattern and how do we get this to look right? What we're gonna do first is I'll actually instance some geometry here so we can see it, and then I'll talk about how we're going to offset things to make it work. So I'm gonna go Shift-A and I'm gonna grab a instance. I'll type in instance, an instance on points node. I'll drop this here, and then I need to have some kind of geometry to instance. So I'm gonna go for mesh primitives, and I will get a mesh circle because that's what we're going to be using to make our scales. Anyways, and I will bring the radius down so they're not overlapping so much. It's a little bit easier to see. Okay, so we've got our scales, and you can see it's an even grid, right? So how do we take this even grid and change it so that we've got an offset row? Like how would we take this row, for example, and offset it? Or actually, just to be even clearer, let's have a look at it. If we added a new row in of vertexes, how could we subdivide this mesh so we could get scales all along here? If you imagine each of these is a face, right, on my grid, and I have 4 vertexes for each of these faces. If I want to have one in the middle, how could I subdivide this so that I get that one without getting any other vertex? If I was to just subdivide it normally, it's going to do this. And that's going to give me a vertex in the middle, which is what I want, but it's also going to give me these extra ones on the side. So I'll end up with circles here and here and here and here as well, which I don't want. So in order to just get one in the middle, I actually need to cut it like this. By creating an X pattern, an X cut right through this polygon, I'm not going to get any extra vertexes. I'm only going to get the vertex I want, which is the one right in the middle. And it's also going to be exactly halfway between both the points on the horizontal and the vertical. So it's going to be right in the middle of those guys, which means it's going to be a perfect row, a perfect offset of the previous and consecutive rows. So using this X cut is going to be really useful for us to achieve this pattern. In geometry nodes, we have a node to create this kind of a cut, and it's called the triangulate node. So let's have a look at what it actually does. I'm going to unplug my instance on points node, and I'll just take the mesh right here and I'll just plug it into the output so we can look at our grid again just by itself. Now I'm going to grab a triangulate node. Triangulate node will triangulate mesh. And you can see here it's taken each of our faces and it's turned them each into a triangle. So it's cut it in half. Now it hasn't created the X pattern, and it's using this shortest diagonal, which is actually going to give slightly different results depending on the shape of your object. So we have very equally sized polygons right now, so we're getting the same result. This is going to give you a different result if we have, say, for example, a sphere. You can have lots of weird cuts in different places. So to get a consistent cut, no matter what the shape or size, we want to go with fixed. So let's switch that to fixed. Now we can go one way or the other. Fixed alternate just swaps the direction. And you might say to yourself, okay, great, let's get an X by, having two of these. Fixed alternate, bring the mesh, and then let's join the geometry, right? Drop this here and then bring this one here. Now suddenly we've got exactly what we're after, this X pattern. But it's a little deceptive because what geometry nodes has actually done here is it's made a cut right through the middle, and then it's made another cut, and then it's joined these two, but it hasn't joined in a way that merges all these such that it creates a vertex here in the middle of each of these points. Vertex count is now 50. It's actually double what it was before. It's because it's actually just taken two versions of this, one that's cut this way and one that's cut this way, and it's duplicated it and it's put them exactly on top of each other. What we want to do is we want to separate these new edges that we've just made. We want to separate them out and then subdivide those. So these individual edges now have a vertex in the middle, so they become two edges. In order to separate out the edges that we want, we're going to use a node called the separate geometry node. We'll drop this here. We're going to switch it from point to edge because we want to separate out edges. And we need to feed a selection here. Now, we're going to be working with the index number. That's what these represent. So we need to feed an index number in here to tell geometry nodes which ones we want. Now, you might be tempted to think you could just put a number in. So if you wanted number 10, you grab a value node, type 10 into it, plug this in, and fortunately, it's not going to actually work. So you can see if we move this around, it's not doing anything but turning on and off. It's because you can't actually put a number in. You need to put in an index, which is a specific type of attribute. Plus, we need to kind of give it a range of attributes. So the way to set this up is first we need to get the index. So there's a node specifically for index. And now we need to say, okay, which index numbers we want. So we need to do some math on this index, and that's how we can then pass it on to this node. So let's go over here, we'll grab the math node and we'll drop it down. And let's go with the greater than function. So I'll plug my index into the value. Now I get this threshold and I can plug this one into the selection. You can see we've also got this dotted line. That means now it's going to be looping through all the values. So it's going to go through all the different indexes and all the different edges in our geometry, and it will spit out a selection that will be everything that meets this condition. So everything that has that's every index that's higher than 0.5. So we don't have any indexes that are in this sort of half decimal range. So we just need to drag this thing up and you can see it start to work, right? Here we go. So let's get rid of these annotations so they're not in our way. So you can see if I drag this all the way up, let's get to the point we've got the right edges. Okay, there we go. So now I've got the edges that I want, right? They're actually selected. You can see here we've got 16 edges now. We've gotten rid of a lot of them. What number is this? Well, let's see. It's 39. We go to 38. Let's just check. Yeah, so 38 is the first time we start getting one of the edges that we don't want. So we just want everything over 39. So why 39? Why is it a special number? It's a bit confusing if you're looking at this many edges, but if we just drop this down to 1, you'll start to see what's going on. I can increase this up until everything disappears except for the edges I want. And bam, there we can see, so around 11. 11 is the secret number that gives me just the edges I want. So why 11? Why would that be the number? Well, the reason for that is, if we come over here, plug this one in, you can see that when we have our triangulated mesh, we've got 16 edges. But when it's just the subdivided mesh, we have 12. Remember that with the index, the first one is always 0. So index number 11 is actually the last index for this piece of geometry. When we triangulate it, these new edges get added on after 11. So you can see here they're 12, 13, and 14, and 15 are these new edges. So by separating the geometry, where we grab everything that has an index higher than the number 11, it's going to grab 12, 13, 14, and 15, which is exactly the ones that we want. Now that logic holds up no matter how many faces you've got, right? The number of edges in your piece of mesh is always going to have a certain index, a certain number of indexes. when you triangulate that mesh, there's always going to be all the new edges are always going to happen after that first group of index. So if you can get the number of edges you have on your mesh before you do the triangulation, and then compare that to how many edges you have after, you're able to get the indexes for just the slices that are diagonal. I hope that makes sense. Once we've got those, using this setup here, then we can subdivide those. So I can come over here and I can grab a subdivide node, subdivide mesh, drop it here just a level of 1, and that will now subdivide each of these guys. So you can see now we actually have 8. So if you just have a look, if we go 0, we've got 4 edges. And then if I set this to 1, we now have 8. Nothing visually changes. And so that means these guys have actually just been cut in half. All right, so how do we know what the threshold needs to be? How do we get that number? We're going to grab the attribute statistic node. Type in attribute statistic. You can also find it under here under attribute. It's one of the only 3 attribute nodes. Now this attribute statistic node gives all kinds of information about any piece of mesh. So I'm going to take my subdivided mesh and I will drop it into the geometry, and I can switch this from, keep this to float. I'm going to switch this to edge, and then I can grab the max value. This is going to be the maximum number of edges as a floating point number in my mesh. So if I was to take this, right, you would think, great, I can just plug this number into here. You'd think it would work, but of course it doesn't. Things start looking pretty crazy. Now, it's a bit confusing what's happening because of the subdivide mesh node. So if I just mute that by hitting M, just turning that node off, you can kind of see what's happening now. We're actually only selecting one edge. So this isn't actually working. This isn't giving us the number of edges. And the reason for that is we're missing the attribute input. What we need to put in here is, what is it that we're looking for? What does this floating point need to be, right? Blender doesn't really know. We're saying we want edges, but we're not saying what we want about the edges. Like, we want like the Z position of every edge? Do we want the X position of every edge? Doesn't know. What we want is the index of every edge. So what's the number of edges? What's the number of indexes that we've got? So I'm going to grab the index, so I can just duplicate this one. And I just plug this into that. And now it's going to work because it's taking the index of each edge and it's taking this mesh, and then it's outputting the maximum value. So what's the maximum index? The maximum index in this particular case is 11. And so when I say take the index, take every index that's over the number 11 and separate it out after we do the triangulate, we're taking those extra edges and we're separating them out. Now, if I unmute this, we're going to subdivide this. We'll get the double bit. And now we've got pretty much everything we need to create the scales in the way we want. So let's have a look. Now you might be wondering, why don't I have like the grids again? Like what happened to the polygons? Like, don't we need those? And I don't actually need them anymore because you can see I've got enough vertexes. You could see that we've actually got the same kind of grid pattern that we're looking for without having to bring in those other edges. So let's take this and we're going to drop this one here. And then we'll take our mesh circle again and we'll plug it into the instance. And bam, there you go. Okay, so now that we've got the offset pattern that we wanted to, this is the most complex part of our setup. What we need now is to just basically make some scales out of this mesh circle. So we can do this pretty easily. What we want to do is we can just have a look at this by itself, probably a bit easier. So I'll just plug this in. I'll get rid of our annotations. I'll go back to shaded mode. And come over here to our mesh circle. I am going to fill it with, let's see, triangles will be fine. See what that looks like if we go into mesh mode. That's what the triangle setup looks like. And what I'm going to do is basically stretch this thing out and scale it around a little bit. And we can create some cool shape using geometry nodes to get this right. We could also easily just model this object. We don't have to do this part in geometry nodes. So it's kind of up to you how you want to do it. It's probably a little bit easier just to model it, to be honest. But you get a bit more functionality if we do it in geometry nodes. We can actually control these values a bit more specifically just to make sure it works. So first thing I want to do is move this section up, right? Let's do that. So I'm going to grab a math node, and I'm going to grab a separate X, Y, Z, and I want to move the vertexes of this around. So I need to select some vertexes. So I'm going to use the set position node. I'll drop this here. And then I'm going to grab the position node. And I'll plug this into the vector. So what this is going to do is take the position of every vertex in this object that we're working on. And I'm going to separate out where is it on the Y. So where is it along this Y-axis? And I want to say, I'm going to grab everything. So I'll plug this into the value. And I'll go less than this time. So I want to say everything that's less than 0. These are the ones I want to be my selection. And I'm going to offset those along the Y. Negative. Actually, I won't go the other way. I don't want to do that one. So we'll do greater than. And we'll go positive. So we'll stretch that out. So we're just stretching out this shape. Next thing I want to do is take this group and I want to kind of lower it down in Z space so that it kind of drops a little bit for me. So I'm just going to do that here pretty simply. All right, so now that we've dropped this back end and extended it out a little bit, these guys are going to kind of slot under each other, okay? So let's have a look at how this affects the overall style. So plug this into the instance and plug this back into geometry. Now, the first problem is we need a lot more than this. So we can do this in 2 ways. We come over here and increase their subdivision, but because you want to be able to put this on different types of objects with lots of different, maybe densities of mesh, probably one size doesn't fit all. So we want to have a control on this that's sort of custom per object so we can set it. So I'm actually going to click the input here and drag it here to subdivision. This will elevate this to our modifier stack itself. So I can now come in here and change the number of subdivisions that I want. So now we can kind of look at how well these guys are overlapping and what issues we might have. So I feel like this is a good level of density, but you can see that they're intersecting a bit too much. Decrease the radius a touch. Yeah, there we go. That's a bit better. So you can see we've got this interlocking pattern where these scales are kind of traveling underneath each other. Now we are getting kind of a weird pattern with these scales. We're getting this bizarre kind of like point here, and that's because of the triangulated faces on our mesh circle that we started with. So what we could do is actually come over here to mesh primitives and grab an isosphere instead. And we could match the radius. And we could plug this in here instead. Now, of course, everything's going to be these, large spheres, but we can shrink it down. Go over here, we can grab a transform node and drop it right in here. And then we can scale it on the Z to kind of flatten it out quite a bit. You can see our other aspects that are going to work. We could also probably increase the subdivision some. And that would give me more of something that works a little bit better, I think. Now, it'd also be good to shade this smooth. So I'm going to come here and grab the set shade smooth node and drop it here. And with that ticked, it will shade all of these guys as smooth. And there you have it. We've got an actual scale pattern. Now let's see how this behaves on different types of objects. I'll come over here, grab a UV sphere, bring this up, and let's click new for new geometry nodes and then grab scales. And you can see right away, we've got a very cool result, but we do have a problem. They're not actually rotating appropriately, which means we need to do one more step to get this to work on anything. And that is to set the alignment of these guys with the surface of our object. Now we're going to input this rotation fix into the rotation input of our instance on points, because this will allow us to rotate each scale individually based on some information that we feed into it. So we're going to use the align Euler to vector node and drop this here. This is always the node you're going to use to align a lot of instances to geometry. So you get used to using it, even if it's a bit confusing here at the start. Okay, so if we take this align Euler to vector and we plug it into the rotation, you can see it doesn't work yet. So it's just rotate everything, but kind of uniformly. It's not really doing something specific. Now, usually what you would do is you would grab the normal node next. You grab the normal node because the normal is the direction that every face is pointing. But you can see if I plug the normal in to the vector, it's giving us some very bizarre results. Even if we swap these around, it's still not quite working. You see, they're really overlapping incorrectly. So what's going on? How can we fix this? Well, what we want to do is actually, the problem is it's taking the normal of our separated geometry. So it's just looking at this new version of the geometry where it's just edges. And that's going to give us some very strange results. What we want to do is actually step back a few steps and grab the normals either from our base mesh or this triangulated version of the mesh. So how do you do that? How do you grab, this normal node doesn't have an input to say, okay, which normal do you want? It's just the normal, which is going to be kind of confusing, but it's always taking the normal of whatever it is that's feeding into the node that you're using it with. So it's looking up the chain, it's going, okay, we're getting this. So this is the one that it's using for the normal. So in order to get the one that's back here, we need to grab an attribute again. We need to transfer an attribute from here over to here. So to do that, we need to use the transfer attribute node. So we're going to be transferring a vector because we want the normal. A normal is a set of 3 numbers that describes the direction that a face is pointing in on the mesh. So if we grab our triangulated mesh, before we separate things out, drag it here to the target. Now we're going to tell it, what are we grabbing? What attribute are we grabbing? We're grabbing the normal. So I want to grab the normal of this thing here. And I want to output a vector. So I want to actually just output the normal itself straight over. You've got this option, nearest face, interpolated nearest, or index. We can probably just leave that set to nearest face. And I'll take the attribute and I'll plug this now into the vector, because this attribute we know now is a normal from this object over here. So I'll plug this in. All right, so it still doesn't look quite right. That's just because the size is a bit too big. We come over here to our radius and we can shrink them down a touch. See there, as we adjusted the size of these guys, they're starting to fit a whole lot better. You can see how that rotation actually works pretty well. Now, there's a few other issues we've got. If I increase my subdivisions on this in the geometry nodes, you can see we're starting to get a real grid pattern. And that's not looking good at all on our sphere, whereas it looks fine on the flat plane. And that's because this is actually a round object. And by subdividing a round object, it's not really giving us the look we want. So if you're using it on something like this, it's probably better not to have this as an option within the geometry nodes. And in fact, come over here and just use a subdivision surface on whatever object you want to have this on, so that it's actually be a rounded set of subdivisions. Now, if I create a cube, Shift A, cube, bring this up, I can place this in my scene, just put it next to my sphere here, and click New for geometry nodes and go ahead and apply scales to it. Right, and I can use my levels to increase this. This is another, using a cube, it's good time to use a subdivision surface modifier as well. So let me just throw on one of these simple, just to kind of subdivide everything and firm up the edges a little bit. And then I can do another subdivision surface, drop it here and keep this one set to Campbell Clark. And then if I set my geometry node level to 1 and pop this to 2, you can see it's starting to round the edges in a way that looks really nice and helps wrap those scales. Now I've created 3 different objects here. We've got a torus, a sphere, and a cube. And you can see through some of these, like with the sphere and the cube, whereas the torus, the scales line up really nicely. So it's clear that you need some kind of value to manage the scale of your scales, for each individual piece of mesh. There's probably a way to do this with math so that you could actually look at like how far away a vertex is from its nearest neighbor, and then use that to be the driver to calculate the scale of the individual scale. And you have like different size scales depending on how spread apart the mesh is, but that's probably a bit beyond where we're at with this tutorial. We just need to create an extra step here for working on our radius, or our scale of our original isosphere. Instead of just working with such a small number, I'm just going to grab a transform node and just drop it here. And then what I can do is grab a combine XYZ node and plug it into here. And then I can just grab one of these outputs here from our group input and plug it into the X, but then I can also take that same one and plug it into each of these. This will allow me to have one floating point number that I can use to change the scale of everything. So instead of 0, if we set this back to 1, everything will reappear. And we'll lose the other ones because we've just created an external variable and it defaulted to 0. So I just need to set it to 1. Here with these guys, grab the cube. Now I can come into this torus, for example, and use this value to fine tune the scale. So I can just hold down Shift and drag until everything's overlapping nicely. Come over here, instead of seeing gaps through, I can grab this one now and just expand the scale up for these guys. Great, now the last step you want to do is set some kind of material on these guys. And that's pretty easy to do right here at the end. We'll just go set material, and we can actually put this on each of the scales individually. If we come all the way back to the isosphere, we can set the material here and just create a material for our scene, call this scales, and then we can select it in the dropdown. And now if I switch to rendered view, I'll just turn off scene world so we can see some light. We're going to get a nice view of our scales, and we've got a material now that we can work with in our shader editor. Now, just to do a simple example of how you might create some interesting looks on these scales, we can create a gradient. So Shift A, type in a gradient texture, and I'm going to grab a color ramp Let's take this gradient texture. We'll plug the color into the factor and we'll plug the color into the base color. And you can see there that it's creating a nice gradient from one side to the other. But if I want to rotate that, just grab a texture coordinate node and a mapping node. Plug the generated into the vector and the vector into the vector. And then I can just rotate the whole thing. So I rotate the whole thing on the Z 90 degrees. And then I can go to the X location and just drag it back. Sorry, drag it up. There we go. Now I'm getting this nice gradient where the base of my scale is dark and the tip is quite light. Now I can set some nice colors. I'm going for like a fish scale kind of look, to like a darker blue, and then like maybe a light, brighter blue. And then I might take my roughness down so they're nice and shiny, bring my specular up. And there you have it. We've got a procedural system using geometry nodes that can put fish scales onto most any mesh. Pretty cool. Hope you really enjoyed this and learned some really neat tricks about how to transfer attributes, move position values around, some complex stuff. So feel free to watch this one again, take notes and try to really wrap your head around these concepts and you will start to fly using geometry nodes. Trust me. Don't forget to hit that like button and subscribe to the channel if you want to find out when we drop new tutorials. And please leave us a comment. Let us know what you thought of this one and what you'd like to see in the future. We'd really appreciate it. Don't forget to check out cgcookie.com. I'm Chris Bailey. It's been great to be with you today. Hope you enjoyed this tutorial. I'll catch you in the next one. Until then, see you later.